Hello. So, we have a girl, and we'll put her to sleep, and we'll toss a coin. If we get heads, we wake her up once, say on Monday. And if it's tails, we wake her up on Monday and on Tuesday, so 2 times. All times, we tell her nothing, no outside knowledge, and she won't remember if she's been woken up before. We only ask her, which coin was it? What is the best answer she could give? This problem is often rephrased as, what is the probability it was heads? Well, I say this is paradoxical, but not always. Only if you ask about heads. This is a common paradox. Is the answer a third or a half? There's 3 ways for her to wake up, but coins can't have a chance of a third, so it must be a half? Well, in practice, if you go through it yourself, each option comes up 33% of the time, so the answer's a third. Not so fast. We asked the percentage it was heads. Allow me to introduce you to the timeline. We have the event for getting heads and the events for getting tails. Now here's where I get to what I've been thinking about. Previously we heard each way she could wake up will come up 33% of the time if you repeat and repeat and repeat. This is as we could flip a coin and then we could tally the results. On heads, we'll give a tally to heads on Monday. On tails, we'll give a tally to tails on Monday and on Tuesday. Now this has importance. Since she has 0 ability to remember if she has been woken up before, she shouldn't really care if it is Monday or Tuesday. She's not being asked anything like, what day is it, or what's the probability it's Monday. She only cares about coins, so whether it's Monday or Tuesday has no effect on her. All which is important is that the coin must flip tails to be asked twice. Think about the rules of the game. We have predetermined, already decided, that she will wake up twice if it is tails. If it is tails, there is no probability that she can be woken up once. So if she was ever awake on Tuesday, she must have been awake on Monday. This makes it so she must be asked twice 100% of the time if it is tails. I give all of this elaboration to say that this means that the probability of waking up on Monday and Tuesday, given the coin was tails, shares the same probability as they aren't independent events. In a sense, they are the same thing. So they gain a combined probability, which isn't necessarily a split probability like a 50-50 chance, but each is 100% and 100% in total, as each can't exist without the other. Since waking her up, no matter the coin or day, is always the same equal thing, this eliminates arguments that heads will be 50 and tails will be split 25-25. They don't split their probabilities in this way, they share it, in a way that leads to some strange occurrences. So we have to tally both days if we get tails, because they are predetermined by us to always happen. We have decided she must 100% of the time be woken up twice if the coin lands on tails. So we start with a coin, we flip it, and it is 50-50 whether it lands on heads or tails. But then when we get tails, which is equally likely as getting heads, we wake her up double the amount of times than if it was heads. So this basically adds an extra half. Well, that's impossible. You can't have 3 halves. A coin can't flip 150% of the time. So the probability must resize in essence, just as a representation. A third, a third, a third. Do you see how the tails basically just sneaks its own extra equal tile on? This comes from when we were tallying. Waking up twice literally adds a half, as 2 is 2 times 1, and waking up the second time is an equal event to waking up the first time. It is really important to get, though, that our own rules have caused them to be equal events. A little conclusion on just this point. We normalize 3 halves to 100%, which we can do because we don't actually have 3 halves. Tails is just going to 100% of the time have her wake up twice. Also, all events of waking her up are the exact same event due to the no extra information rules and her apparent amnesia, making both events for tails in practice the same event from her perspective. This causes tails to add an extra sneaky tally whenever it is cold, which forces the 100% to divide 3 exactly equal times, even though coins are 50-50. You could think you've made it not 50-50 by always waking up twice on tails, causing the coins to flip 150% of the time, but as time is constant, this makes a thirds distribution in 100% time. So this is where the equal thirds comes from, and this is a top-down approach. I believe you can also come from under 100% somehow. Also, if we say woke her up 3 times when it was tails, we should then expect to have a 25-25-25-25 data spread, as waking up is all the same thing. This is the strange relationship always waking up a predetermined number of times has on tails. But look at the timeline. The event of flipping a coin and the event of in some way waking her up are 2 very separate events. The coin flip must always happen before she is woken up, at least on Tuesday being the defining event. It's fine if she's awake on Monday and we haven't flipped the coin, as nothing different would have happened yet. The two events are distinctly chronological. The whole thirds thing only comes about when we look at the specific days. What is the probability it was tails and Monday? Well, we only tally it 33% of the time. I said earlier that the coin is no longer 50-50, but actually it's only no longer 50-50 if you look at the secondary events. See, if we look at the first events, where the idea of ever waking her up twice doesn't exist yet, of course it's 50-50, we're just looking at coins. 50% of the time it will be heads and 50% of the time it will be tails, and you can't change this, as just looking at the first event, she shouldn't care what day she's been woken up. Even then, it is important to understand that there is zero perceivable difference to her about when she wakes up on tails, and tails just skews the probability like that in a sneaky way. If you ran a separate tally at the same time, only counting heads and tails, or the first event, it will be 50-50. So that is why a clear definition of what you're asking about is needed. Are you talking about the first event of flipping a coin, or the secondary event, the one where she wakes up in differing ways? Now here's where it becomes an English problem. We asked what is the probability it was heads, and this is a common question put to people for this problem, almost like someone planned this. But here's the issue. We need to clarify between whether we're considering the first event or the second event in our chronology. If we ask about tails, this is pretty obvious contextually. What is the chance it was Tuesday? Well, 1/3. How often is it Monday given it is tails, which would give a half, as where they're considering the identical tails probability from before and artificially splitting it in two, which I said you couldn't do, but here makes it more well defined in terms of time and causes the 2 days to be actually distinct just by asking about them, so it changes the question really, but it's a fun example to consider. Here we must be referring to the second event, as we need to specify the day of awakening. What's the chance it was tails? Well, since both events considering it as tails are just the same thing really, nothing is perceivably different. We can and are able to only consider the first event, therefore 50%, we're looking at the first event. But if we ask about heads, everything can easily break down. This is as we will no longer have the benefit of 2 days. This benefit allows us to contextualize which event we should consider, in difference to the single coin outcome which it was, as there is now only 1 day to combine with the single coin flip outcome, the ones lead to confusion. How often is it heads and Monday, which is very different than Monday given heads as I just rambled about? This is very obvious, as we have defined what we are looking for at the days, so we may look at our little graph and say, yep, 33%. But wait, it's always going to be Monday when it's heads. Heads is no other option. And how often does heads come up? By half the time, of course. This could be interpreted the same as asking, what's the probability it was heads, which is the most ambiguous thing ever. Were you asking about the coins or the waking up events? In this way, it is ambiguous to ask, what is the probability it was heads, as there is circumstantially insufficient information in this specific sentence, as the answer will change based on which event we choose to consider. This is specific for heads, as in tails, the including of a second waking will contextually differ its meaning from the first event. Tails is 1-2, while heads is 1-1. This 1-1 makes it difficult, actually impossible, to understand which event to consider without an extended auxiliary redefinition, as they are grammatically identical. So in the end, the answer to this problem changes based on what time you consider it in, and as the way people commonly rephrase the question is ambiguous. Going back to where we started by asking her which coin was flipped, the best answer would at first seem to be tails, as considering the second event, where she is in time woken up, there is a combined 67% chance where it is tails. 2 wake-ups are tails, whereas only 1 is heads. However, just like every possible way she could wake up is equal, and her probability is shared and not split between tails' 2 days, due to us having a predetermined amount of wake-ups, this third split is actually false, and a trick that comes about due to tails' definite adding. We get heads half of the time, and we get tails half of the time, but when we get tails, we have predetermined to always have 2 consequences instead of 1. The fact that we give her no more information and she lacks memory makes it so each event is independent, and from her perspective the same. This rules out possibilities for a 50-25-25 split, as each split must be equal. This artificially causes a third distribution of probability when tails has 2 days, and remains equally spaced with the addition of more days to tails, whereas in reality the spread is controlled by a 50% chance of heads, which goes to the first item here, and then tails claims the rest. Tails can't simply sum its probabilities, as all the events are the same. Having tails on Monday or Tuesday doesn't change the fact that she has tails. So, all that this really shows is heads and tails are equal, 33-33 or 25-25, which all simply show it is 50-50 or 1-1. How low the number is simply represents how many days we've decided tails will have. Therefore, there exists a chronology where a coin is flipped and then she either will, in total, wake up once or twice, I say in total as we don't even need to flip the coin all the way until she wakes up on Monday and has guessed, as the defining differences for which we are concerned only happens after this point. This 67% chance of landing tails is untrue, coming out of our own strict rules as the game makers, and doesn't reflect the reality we are concerned with for this consideration. There is a 50% chance of getting heads and a 50% chance of getting tails, but 100% of the time when we get tails, we must add another equal part which skews the data into thirds, and we account for the fact that we can't have 150% of time or 150% of a coin's probability. Because of this, it is neither better nor is it worse for her to pick either answer.